Hello class, this is Mr. Goodman and this is lesson 3.5, max-min word problems, also known as optimization. And this is basically a word problem that's going to seem similar to the 3.4 lesson. However, we're going to be looking for a maximum or minimum, therefore we're looking for a vertex, therefore we need to get our equation into vertex form. So let's go. This first question says there's two numbers that have a difference of 10. What are their numbers if their product is a minimum? Well, what the heck does that mean? It's probably the most common question I get. And when we say the product is a minimum, that's lowest possible multiplication result. So here are a couple examples in numbers who have a difference of 10. 10 times 20, 5 times 15, 0 times 10, negative 1 times 9. You can see that their product is different, and this is clearly the smallest product of these. But is it the smallest product possible? Well, we're going to figure that out. We could do guess and check, but of course we're not. The very first thing we're going to do here is we're going to say that let x be our first number and y be our second number. Now, again, I said this in the previous lesson, you don't have to use a y value. You can skip this step if you know how to skip this step. But if you don't, just continue this way. What that means is that we're going to have our first equation be x minus y equals 10. The difference between the two is 10. And the minimum product that's created is created when we multiply the two numbers together. Well, we can rearrange this equation so that we get y equals x minus 10. What I'm going to do is I'm going to follow the pink brackets here. I'm going to substitute the value of y into the second equation. So x minus 10 is going to go right in there, and I'm rewriting this, and there it is. Pink brackets, it's consistent. So we substitute the value in, and if you have skipped the step where you don't care to use y, well, this is where you would start off if you were able to skip steps. From this point, we're going to distribute, and that's a standard form equation. Now, because this question asks for a minimum, you have to know what it's going to take to change a standard form equation into a vertex form equation. I hope it's on the tip of all your tongues right now, and that you're saying, altogether, complete the square. So I'm going to do that quickly without going through it because you should already know how to do that. And there we have it. Looks like we have a vertex of 5 and negative 25 when it's in vertex form. What that means is that our x equals 5, and when it does, the minimum product is negative 25. So let x equal the first number, and really, x minus 10 is the other number. So, therefore, the numbers are 5, that's the first number, and, well, 5 minus 10 is negative 5. And their product, when they multiply each other, is negative 25. And that's how you do it, guys. This question I have some problems with. My problem is that it's completely unrelated to the real world. It has nothing to do with anything that appears to have practical value. Well, let's say you go to a store and you buy a jacket. Well, it's priced at a certain amount. If the retailer prices it too high, then yeah, they'll make more money when it's sold, but they're going to sell less. Or if they price it too low, they're going to sell more because it's cheap, but they're not going to make as much money because they're selling it for less. So this is what we call a revenue question, or what I call a revenue question. And it's basically what happens when you have a certain cost of something and a certain number of people buying it, and the question is asking, what is the greatest revenue? Here is a Wiggles concert, $20 per seat. 600 people will buy those tickets. It's $20 a seat. But a survey says that if the price is decreased, by every $2 of decrease, 100 more people will come. So more people, that should be more money. But what ticket price results in the greatest revenue? And because I see the word greatest, I know that this is going to require a vertex. So here we go. The very first thing we're going to do, and this is a bit of a memorization piece when it comes to revenue questions, is that the variable x, is going to represent the number of price decreases. So not what the price decrease is, but how many times it is decreased by 2. So that's a really important piece there for all revenue questions. The other memory piece, so to speak, is the formula that is created out of this. And it's pretty logical, which is that revenue, how much money you make, is really dependent on the cost of something times the number of people that bought it. I mean, think of it this way. If you had jackets that cost $100 each and you sold 5 of them, you could tell me that you made $500 because 5 times 100 is $500. That's how we determine the revenue. We're going to put the values of this into here, and that's probably going to be the hardest part about this particular question, which is how do we take this information and stick it in here? Well, I'll show you and then it'll seem obvious, but I try to slow down at this point so that you just sort of can think about it for a second. The ticket cost is $20 and the number of people is 600, but that changes depending on the number of price decreases. So revenue equals 20, and the ticket price is $20, but we decrease by $2. How many times do we decrease by $2? Unknown. The number of people is 600, and it's going to increase by 100 every time there's a price decrease, but how many times is there a price decrease? We don't know. So that's how that comes about, this piece here. And if you're struggling on how you get from here to here, all I can say is that revenue questions generally follow a similar pattern. At this point, we're going to FOIL it, put it in standard form, and because we're looking for a vertex, we're going to complete the square. And just want to remind you here that when we put in our new C value, we're going to take out the negative version of the new C value. Let me take a step back. We're going to common factor from the first 2 terms, negative 200, to make this an x squared. And, because this is a hard trinomial, and the new C value, the negative version, is going to come out of the brackets. And as it comes out of the brackets, it's going to get multiplied by negative 200. That's why that negative 4 became positive 800. So there's our vertex form. The vertex is 2 and 12,800. So what is that telling us? It tells us that the x value is 2 and the revenue, which is the y, is 12,800. So at 2 price decreases, the max revenue of $12,800 is reached. So $12,800 is the maximum revenue you can get in this situation. However, the question is asking, what is the ticket price that results in the greatest revenue? The ticket price starts off at $20. But what happens? Let me sort of do it this way. At $20, you're going to make $12,000. 20 times the 600 people. But at 1 price decrease, the ticket price is going to be $18. At 2 price decreases, the ticket price is going to be $16. And that's going to give us our greatest revenue. So it's not $20, it's not $20, we go down $2 twice. And that's the ticket price, $16, that gives us our greatest possible revenue. I felt I was going a little fast on that, but I'm really trying to fit in what's normally a lesson into these 10 to 12 minute videos. I hope that made sense. The homework that I have related to this is very tightly connected. So questions 1 to 4 on mind-busting optimization questions I want you to do, and questions 13 and 14. Answers are at the bottom. If you really struggle with this, I can post the solutions, but hopefully you recognize the pattern and you're able to kind of do this on your own. I believe we have one more sort of word problem type question in our next lesson, and then it's time for the final assessment in this particular unit. So I hope it's going well for you. I hope that this whole situation is at least tolerable. And that's about it. Before we go, I'm going to show you, I showed you my favorite coin last time, I'm going to show you my favorite bill. Yes, I have a bill collection as well. Do you guys know I was rich? That I have $10 billion? This is a Zimbabwe bill, when they had hyperinflation a couple of years ago. If you don't know what hyperinflation is, it's hilarious in some respects from the outside, because money becomes not worth anything and then they have to make it larger and larger. But if you're experiencing it, it's a not fun situation at all. But then you get stuff like this. By the way, this bill in Zimbabwe is worth nothing now. And yeah, that's it. So I hope that lesson was easy for you to follow and somewhat enjoyable. And yeah, that's about it. Okay, Mr. Goodman signing off.